Hi there, my name is Matt and I'm a content designer here at Autodesk. Today I want to talk about my 2020's newly exposed ability to uniformly remesh or retopologize a model all at once. These two algorithms are still young, there will be a lot of improvements and optimizations coming to them in the future. That said, they're very powerful as is, especially when it comes to more organic meshes like this bust. To start, remesh allows me to add detail to whatever I have selected. So, for example, say I wanted to sculpt an ear on this head. Currently, there is not enough polys to allow me to do that. So I'll just select the faces in this area, then go to Mesh, Remesh. This adds a bunch of evenly distributed edges in my selected area, giving me the components I need to sculpt properly. I can even adjust the spacing of those components via the Poly Remesh node in the attribute editor to give me more or less detail as I see fit. This way, I can tweak the resolution of the areas I'm working on as I'm working on them. Once I'm done sculpting the individual areas, I can use remesh on the entire mesh at once to even out the edge distribution. Now, obviously this has turned my entire model into tries, which is fine for sculpting, but not exactly ideal for deformations once I start animating. This is what Retopologize is for. I can track the progress of Retopologize in the output window. Then once it's done, I get a nice quad-filled mesh. Just like Remesh, I can tweak the Retopologize settings in the Poly Retopo node. But because Retopologize is a lot more complex, this node comes equipped with a handy pause switch. Simply turn it on, make whatever changes you want, then turn it off to rerun the algorithm. So that's all well and good for a simple bust, but what about a more complex character? Well, in cases like this, you may need to do some cleanup before retopologizing. This mesh was created by a 3D scanner rather than by hand. 3D scanners are pretty amazing tools, but they're not perfect. If we look closely, we'll find a bunch of problems created by the scanning process. The most obvious of these is that this mesh has a bunch of small holes in it. Unfortunately, these are really going to mess with our algorithm. In this case, even using the mesh fill hole command won't work because it's going to fill all these little holes with one giant face. Instead, I'll need to manually weld these shut or bridge them using the modeling toolkit. Next, if I go inside the mesh, notice there's a lot of internal faces in here. These are unfortunately creating a lot of non-manifold geometry. Things like floating faces and faces with no thickness. These also cause problems for the Retopologize algorithm. I can try fixing them by selecting the mesh and going to Mesh, Cleanup. In here, you'll find options to fix things like non-manifold geometry, as well as lamina faces, zero-length edges, n-gons, and so on. You want your mesh clean of all these before running Retopologize. Now, on some simpler meshes, this will work just fine. Unfortunately, in this case, the number of non-manifold vertices is so high and their configuration so complex that all cleanup was able to do to fix them was separate the vertices. But this technically creates a hole, which is also problematic. To fix that, I'd need to remerge all these overlapping vertices. But of course, that'll make them non-manifold again. The only way to escape this endless loop is to go in and manually fix these vertices by deleting the problematic geometry inside. To figure out where all that bad geometry is, I can switch the cleanup tool to select mode and run it again. That way, it'll just show me the problem vertices, of which there are a lot on this model. Then I can either apply a vertex color to identify them, or add them to a selection set. before manually going in to fix them. There, all clean. The last big no-no on this mesh has to do with hard versus soft edges. This is important if you want to use its Maintain Hard Edges feature. With it, Retopologize will do its best not to change hard edges on the mesh. This is a good way to ensure a crease or other surface detail doesn't get smoothed over from the old mesh to the retopologized one. However, if I select this model and go to Display, Polygons, Hard Edges Colored, notice that all the edges are hard. This doesn't give the algorithm room to do much of anything, so in general, you want to soften as many of these as possible. And again, I want to stress that this mesh is an absolute worst case scenario. Usually you won't have to do this much work to get it in good shape. But even if you do, cleaning up a mesh like this is still a lot faster than retopologizing by hand. And once you do get it in a good state, the algorithm can generate some truly amazing results. Once you're happy with the retopologized mesh, I highly recommend deleting history on it before doing anything else, just to ensure the node doesn't execute again since it can take a while. And then I'll just reshow my original mesh, and shift select it and the new mesh, and use mesh transfer attributes to transfer over the UVs. Finally, I just want to mention that Remesh and Retopologize work best with organic meshes right now. It's still possible to get good results for hard surfaces like machinery, but you'll need to fiddle with the options a lot more. If default values don't work, I'd recommend remeshing with a low edge length and high collapse threshold. Then retopologizing with high regularity and face uniformity with low anisotropy. This will prioritize regular face sizes and less smoothing. And as I mentioned at the beginning of this video, these are still very young algorithms. Our engineers are working hard to improve and make them even easier to use in the future.